Okay, so let's now understand why do we need a multi-stage Docker file. And to understand that, let's look at the single stage, a traditional Docker file that we use to build our applications. And let's take a very simple Docker file with only few steps. Let's say I'm writing this Docker file. I'm just demonstrating this with very simple instructions. Let's say the first instruction is always have to be from has to be there, which defines your base image. Then you take, maybe you can create a work directory, and then you copy over the source code. And once you copy over the source code, you build it, you compile it, you publish your application, and so on, using some run instructions. And finally, let's say you have the CMD. You may have multiple run instructions as well. So one for compiling, one for publishing the application, or doing some additional things, or installing some base packages, and so on. And then you have the CMD instruction, which actually runs your application. And then you take that Docker file and feed it to the Docker build image. Let's look at the resulting image and what you get inside that image. Now we've used the from, and this is a build process, so we're compiling the application and so on. So we would definitely have the build tools in this base image. So this image contains, so we take that base image, and this is the final image that we're building and publishing, and this is what we intend to distribute it to production or to the client. Now this image contains the build tools. What else does it have? We use the copy instruction, so it will also contain the source code. So that source code goes in the, and sits here in the final image as well. Then we have the runtime to run your application, which is definitely needed. And then the actual application itself. Now, out of these four, let's find out what is needed. So you definitely want to distribute and run this application. So application is a must. Along with the application, you need the runtime. Let's say if it is a .NET application, you need a .NET here. If it is Java application, you need a JRE here, and so on. This is needed as a dependency for your application. So both of these are essential components. Let's look at the source code. You definitely do not need the source code in your final image that you want to distribute to your clients. Shouldn't be there, for sure. Along with that, build tools are just redundant in the final image. Final image with just an application and a runtime would be enough. Why do we need these two components, and how do we get rid of these components cleanly is where multi-stage Dockerfile comes in, because we don't need these two things, and the problem can be fixed with a concept of multi-stage Dockerfile. You might have guessed it already. Now let's learn how the multi-stage Dockerfile would work and what approach does it take. So the similar Dockerfile can be converted into multi-stage by adding two different stages here. One could be just for building the application. Second, with just the application and runtime, just to package the application. So I can call this as one as build stage, second as a package stage, and so on. So let's find out how the Dockerfile with multiple stages would look like. I'm just demonstrating here two stages, but it could be as many stages as you want. One for build, one for testing, one for publishing, and so on. And then when you create the instructions for a first stage, you will alias it as something. Let's say build here. Right? This is not a must, but this is definitely useful. And this is where you actually build your application. This is where your build tools are. You copy over the source code, and then you run commands to compile your application. Let's look at the second stage. Let's call this as the build stage. And then we have a second stage, which will just have the runtime along with application. The purpose is to just get these two components. So what do? You just start with the runtime. Let's say for a Java application, you just start with a JRE, an image with the minimalistic file, and then you copy over a file from build. So whatever you have compiled here and created an artifact, you take that artifact and copy it here using copy -- from build here. And then you add the command to actually run. So this is the build. This is for running your application, just to run time. Let's find out what would happen if you provide, this is just one Docker file. And if you provide this Docker file to the Docker build instruction, it's two stages. So the first stage creates an image with the from here. This is going to be your SDK. This is where your build tools are, and so on. So your build tools are here. What else do you get in this image? You also have your source code. That's where you copy it to. And then you have an artifact here, the application or the application artifact that you built, and you take that and copy to this stage. So this stage is going to create a new image. So this image will not be tagged. This will be an intermediate image. This will remain as an intermediate image as part of the build process. And then the second image is what you will call as a final image. And what will it have? Just a runtime, because the second image that you use with the second from instruction here will just have a minimalistic runtime image. And then you take the application, the artifact, and copy it here using an instruction such as this: copy from build. Build is referencing here. You could also call this as stage number 0. So from 0 it will also work. This is 0, this is stage number 1, and this is your final image that you would tag and distribute it or run it in production environment. Now if you look at it and compare it with this, it only contains app and runtime. That's it. That's a simple image, a lightweight image, and that's what you desire. It doesn't have an application code, source code, doesn't have the build tools. So we got rid of it by using a multi-stage Dockerfile, and this image is then remains untagged, and it gets deleted when you use docker image prune or a command similar to this. And this is why you need a multi-stage Dockerfile, because it solves the problem by allowing you to have just one Docker file, but you can do two different tasks as part of two different stages, and you can share the files between those. And you can have another stage for just testing. So you build it, then you have another stage where you run tests, and then you have a final stage where you package your application. And this is why multi-stage Docker files are extremely useful. And this concept was actually added fairly recently. Docker was created in 2013. So this multi-stage concept was added sometime around 2017. Before that, this was a long pending issue, because what people used to do would they would write two Docker files, one for the build stage. They would run that Docker file and create an sort of intermediate image. From there, they copy over their artifact to local machine. Then they use another Docker file and copy that artifact to that, using a copy instruction again. So it was a two stages actually, manually you would have to do, but now that has been combined into one single multi-stage Docker file. And this is a fantastic concept, definitely very useful. And if you're a developer, you must know about multi-stage Docker files. So that's multi-stage Docker files for you.